Okay, so in this video, I'll proceed with the explanation regarding to our controller unit of the binary to BCD converter. So by utilizing one hot method, we are able to obtain the controller unit circuit is such like this, which is simply like the same of the concept of finite state machine. So talking about finite state machine, I'll break it down for each of the state in terms of the conditions. So starting with S0, so it's simply easier to be understand, which is the initial state whereby there's no input at all, neither from the input of go and also the input value for either S0 or S1. So in that case, S0 will be standing for the meaning of holding its on current state. Whereas when there's a case of both of the S0 or S1 as well as go is being set as high, which means that the sequence coming from go, so initialization will be verified, then the state will be jumped from S0 to S1. So, and thus in S1 we're gonna perform the binary to BCD conversion. And for the whole process, once it has reached for a cycle, then the 0 here we're gonna detect with 1, and then from the state of S1 here, we're gonna detect the 0 or 0 as high, then it will jump to the next state, which is S2. And in this case, the S2, you're gonna have an output of 1, where when the cycle of the whole machine of the binary to BCD conversion has been done. And once you want to start again the whole cycle, then the value of output we're gonna be reset, and then the state of S2 here we're gonna going back to S0. That will gonna be all for the explanation regarding to controller. Then I'll back to the top level here. So this is a controller that we have been built in the schematic just now, and here we implement it together with the data path by integrate them together. And meanwhile, we also design for the 4 buttons, which is go, reset, S0, and S1. In this case, by setting them each respectively with 1 level 2 pulse. In this case, it will be able to filter out the glitch coming from the input. So for the controller here, simply it will be just controlling for the input signal of 0, and then it will be sending the initialization from the controller itself to the data path, which means that it's gonna be acting as a main controller for the data path, just simply like a switch in this case. And yeah, of course, there's a output value here to detect when the binary to BCD conversion has been done with 1 cycle. So yeah, and for our just compile to show this top level is success. And then next we're gonna go to the waveform of binary to BCD top level, and then we'll run the simulation. Alright, so this is the result that we have obtained from this simulation here. So in this case, the reset that we are applying is actually at the high, which means that it reset the value when the reset is being set as input 1 in this case. So the first example that we are trying to apply is S1 is it has been pushed for 8 times, which means that the input of 1 is being inserted for 8 times. So in this case, that you can see from the output of the binary here, which is why it has obtained for 8 bits of the 8 bits of the binary 1 in this case. And after it's being converted to BCD, so this will gonna be the BCD number that it has been obtained for output. As you can see, the output for both binary and also BCD is being obtained and converted once the goal is is being pressed and the clock positive edge is being detected. And yeah, so another thing that I wish to emphasize is you can see that during the process here there's an input high from the valley itself, which indicates the whole process of the binary BCD conversion has been completed. So same goes to the rest of the example at the back here. Like just that the case that we are trying to apply is different, which here we have pressed for S0 for 3 times and also S1 with 1 time. But in this case, S0 and S1 we are trying to press it simultaneously. And in this case, for the case of the S0 and S1 pressing simultaneously, we're gonna be obtaining the result of the output value is whole in this case. So the go button is being pushed, and the same thing will gonna happen. The process of binary BCD conversion. As well, you can see the output value here will be set as high. And then you can observe from the binary here, this 20 is being shifted from right to the left. So yeah, I believe that's gonna be all for the explanation for simulation. Then in the next part, I will proceed with the hardware implementation. So here I'm gonna show the hardware implementation of our final circuit, which is BCD to binary to BCD converter. Since we are doing for 8 bits, so that's why we install for 7 display of 3, which indicates for 8 bit of BCD. And here we also install for 4 buttons, which are representing reset, go, input 1, and also input 0. And without further ado, I'll demonstrate with one example, which I'm gonna give 8 bit of 1 in this case. Set, go. So the output of 7 segment display, we're gonna show 255, which is actually in another case of binary is represented by 8 bit of 1. So I'm gonna reset it, and let's do it with another example, which I'm gonna give it to with input 20 and go. So now you show another output value, which is 248, which indicates the binary number has been inputted with 0 input by shifting from the left, which means the binary output in this case is 11111100. Okay, I'll reset it again, and then I'm gonna demo another example here, which is I'm gonna press 8 bit of 0, and 1, So in this case, the output signal is showing 001, which it means that there's only input one bit of input 1 being inserted and shifted in the binary output. So that's all from us. Thank you.